Okay, so let's continue the discussion with so we talked about insertion. So I gave a lot of examples on that, several examples on that, and then let's go with deletion. Okay. Suppose so if we have inserted several items. So we have, suppose we have 3 items. Okay, so let's take this example 56. Suppose the memory addresses of these items, suppose this one is, so I'm putting just numbers, right? Suppose the memory address of this one is so this memory address is here. This memory address is here. This memory address is here. Here, none. So last act, none. Right. So that's why we put these arrows like this. They are referring to this. Okay. So I put arrows like this. Right, like this. Okay. Suppose if you want to delete the first item, we can delete any item, but suppose first we consider deleting first item. Delete first. If we want to do that, what are the changes that we have to do? The main change that we have to do is we have to change this into this value. How can we do that? First variable, this variable has to be assigned with this. What is this? Actually, it is currently first is this one. That means this one. first. So this is first now. First කියලා කිව්ව ගමන් එන්නේ මෙන්න මේකට. First one's next is this one. Is assigned to first. First is assigned with first dot next. So that means this value, it would be copied to here. It would be copied to now. It is not referring to this one anymore. Now it is referring to this one. But still, the value of this one is what we can do is we can change that too. If we assign these values next to these values next to null. If we can assign this one to null, then this is isolated now, no connection with our previous linked list. In order to do that, we have to do something, right? New variable should be created. New variable should be created. Node temp. Node temp, the first, right? Before doing everything, node temp node is assigned with first. Then we can do this first. Then temp dot next can be assigned with null. And then we can return the temp. Deleted value can be returned. We can return this value. Very, very simple. If I go back to the previous explanation, in the example, first node is removed from the list. In deletion, there are just two steps. First, assign the first node, the node to be deleted to a temp variable. Then set the first property of the linked list to the second node. First property of the linked list to the second node. Finally, set the next property of the temp node to null and return. Actually, if you don't do this, but still it would work. But it's better to do this for the safety. We remove all the connection with the linked list. We make this isolate. Remove all the connections and return. So, however, these are the two steps, means two steps. Right. So, if I add public node is returning here, node delete first. We assign the first item to be deleted to a first to a temp. Then first item is replaced with current first dot next. Actually, we cannot do this in our implementation. We have to do that set dot get no, get next. First dot get next. First. Go set first. Set first. Can you set first, or you can directly assign, because this first variable is here, which we can access directly. That you can do this, or you can just assign and then temp dot get next, no, set next. Temps next is set with null. And that's all. Is it clear what we are doing here? The tricky part is this one, only this part. First assign with first dot next. Make a first. A next එක කියන මේකනේ අන්න A value එක first එකට assign. That's the delete. Is it clear? Delete first, huh? Is it clear? Any questions? Any questions? Okay. Let's move on to display list. How can we display list? Display one item at a time. Public void display list. Right. So I'm using original list. This value would be here. Okay. So linked list is like this, original linked list. Suppose if we want to display one item at a time. By displaying, we just display the value. We display the value. This value and this. In this case, we have to start from the beginning. When we are displaying, we need to get the help from another variable. Let's call that variable current. Right? Current variable. Current variable's type is node. Right? Node type variable. First, we assign the current node with the first. Here, display all items in the linked list. Okay. Node current is assigned with first. It's obvious, no? Right? This one would be assigned with the first node. Now it is referring to this one, current. Then display the current dot data. Current dot get data. Current in this like in our slides implementation, it would be current dot data. Current dot data. So that means this value would be displayed, right? So then we have to go to the next one. Current should be assigned with current dot next. Current dot next means this one, this value. So this is the current. This is the current. Current is this one. Current dot next means this one. This value should be assigned. That means that value should be copied. With that, actually, with that, now current is this. Because this address is here, current is assigned to this one. So we have to do that in an array. Sorry, not in a loop, right? While, so let's see the condition later on. Current dot data, and then current is assigned with current dot get next. While current, okay, so current dot next වලට යනවා, print කරනවා current dot next වලට යනවා, right? So the next one would be printed. Then current is assigned with, now current is this one, current dot next is this one. That one would be assigned. Now current is article print 23, and then current is assigned with current. Current is now this one. Current dot text means null. Null would be assigned. Right? When current becomes null, we can stop. So that means that's the last one, right? So while now we can put the condition. While current not equals That's all. So let's see whether it works. My list. Display. Display list. Let's see whether it's working. Okay, see. So you can add some fancy things like just print. So we can add the index. Index. Yes. Oh, starting with 1, no problem. Like this, item 1, item 2, item 3. So display items. See, current is moving like this. See, current. First, current is assigned with the first one, and then current dot next is assigned to current. So then current moves to the next one, and so on. So to display the list, start at first and follow the chain of references from link to link, node to node. A variable current point to or refers to each link in turn. It starts off pointing to first, which holds the reference to the first link. Following statement is used to change as current to point to the next link. Current is assigned with current dot next. This. In our case, it is current is assigned with current dot get next, based on our implementation here. Okay. So list, first to last, node first, and then while current is not equal to null until end of the list, current display node. Right, so we have a display node without just using in node, we didn't implement that. So you can add a display node, display this node method here. If we have that, then that method can be used. In your examples in slides, so they have that. See, display node. In node class, there's a method called display. That method has been used here. And then current assigned with current dot next. Move to next. Just empty. See, so this is an example, like insert several items and then display. The same thing that we have done here. And you can, if you want, you can delete an item. So delete. And then after deleting, again we can display. So delete first, it is returning a value. Deleted item. You can just print. Deleting item, deleted item, get deleting this side and then display. So let's see. I forgot to add. So now it will be these are the items and then deleting item 23. So now the items are 23. The first item we deleted. So we are inserting values. Sorry. We are inserting value. It is the other way around. The other way. We are inserting values. First inserted value would be last. Insert කරන පිළිවෙලට අන්තිමට insert කරපු එක තමයි මෙතෙන්ට. එහෙමයි තියෙන්නේ. 23 300 56. If we delete first, this would be deleted. Like this. This would be deleted. Insert first. So insert as the first item, right? So after this would become the first. this item. Then finally, this should become first. Okay. Deleting all the items here. See, while list is empty, deleting. So we can do whatever we want with the methods that we implemented. Right? You can do whatever you want. So this is just one example, like deleting all until it is empty. Right. Any questions? Any questions up to now? Is it clear what we are doing here? Deleting, inserting, any questions? Anything? Domingo, is it clear? Wajira, is it clear?
Yes, sir.
No questions? Right, okay. So I'll move on to the next one. So we are doing various experiments with this our implementation. So that's what we are doing here. We can do many things, as I told you, like we can insert in front, at rear, or any other place. We can delete any item. So that's the flexibility of linked list. So we start with only inserting front or deleting front. We can do other. So we are checking, we are exploring other possibilities, right? So here, finding specified node. Actually, this is what we call searching. If you want to search any item, so if you want to search any item here, what you can do, if you want to search any item, if you have the linked list, if you want to search for an item, whether it is there, then what you have to do, you have to start with the first one. You have to go for linear search actually. Linear search. Search in a linear manner. First check the first one and go to the next one and go to the next one and so on. You can do that using the display method. In display, you use current. You can do the same. You can use the same. First, it is assigned with the first. Check the value. If it is equal, you can stop. Otherwise, you can go to the next one. And so on. To find a specified node with a given value, an extension of display list method can be used. Same variable current is used to hold the current position at the list. Search start from the first node until the specified node is found, until the value is matched. Move one node to the next using current, assign current node next. Like this. If value is found, stop moving to the remaining nodes and return the current. Yes. Like this. Suppose we have to find the node 33, current, assigned with first, and then we check the value, we compare the value, and if the value is not there, we go to the next. If anywhere the value is found, so here value is found, so we can return that value and we can stop. Right. So let's try to implement that. Actually, this is searching. We return the value node. Let's see. The return type, let me check again. Later, I will change this. Okay, so then search. Search, or you can use find element. Find item or whatever. I'm using search. So the value has to be given. Search for a given value. Okay, so let me do it. Current is assigned with the first, right? While, so let's copy this for now. I'll print it. And just say if we can check if current dot get data equals to value. Then actually we found the value. Then we can return. So here we can return the node, or we can return the index. Return current. Else. Right. Actually, else is not necessary here. If this is not true, anyway it will come here. If this is true, it will just stop while anyway, because it's returning. Right. Finally, it will return. If nothing would happen, return current. Anyway, return current. Current would be null. So it can directly return null. That's also possible. The other way is, right. So let me check. Yeah, node is returned. Right. So that's a one implementation. We can do the same, right, without using this condition here. We can use this as a condition. So while current.get data is not equal to value. While goes until the value is not equal. The current data is not equal to the value. So here, current can be returned. Yeah, return. Actually, this is not necessary. If we do this, this is not necessary. All right. So here, if it is null, current next is null, return null. Actually, this is also not necessary. This is not necessary. No. This is necessary actually. This is necessary. Or you can put that condition here. Current get data not equal value and current index is not necessary here if we are returning this. We click down the value. So this is one implementation. This is the same implemented in a different. This part is checked here. Either implementation, it will do the same. Both they will do the same. Is it clear? So you have to check this implementation, right? You have to go through that again. But did you get the idea? Searching. Again, searching one by one. Linear search. So if I ask you to add two search methods, for example, this one search value. Or if I ask you to add search index. Index. Search position or where it was found. Then int could be returned. Zero or one. Let's go here. So here, what I'm going to do is, I'm going to and if current equals that case return -1 or something else. Is then index is incremented, index is returned. Yeah. Search position or search index. කියන්නේ මේ item එක කොහෙද තිබ්බේ කියලා මේකේ කියනවා. value එක හොයාගත්තොත් ඒ value එක return කරනවා මේ. Okay. Fine. Method name here is find, but in my implementation I did it as search. You don't have to worry about this implementation. This is additional. This is something additional. You can go with this. Search. So then deleting specified node. Yeah, so that's the last method. So that means deleting any item. Deleting any item. Suppose if you want to delete the item with 3, 4, 5. That means this item. If you want to delete this. By looking at this, we can directly decide, but actually, so we have to search for that item. Search for that item first, and then we found that, and then we delete it. So we have to go through one at a time. So that means we have to use this. We have to use this method and then find that item and delete. To delete a specified node with a given value, an extension of find method can be used. This method, extension of this method can be used. Same variable current is used to hold the current position of the list, and extra variable here we need an extra variable which is called previous. Extra variable is used to hold the previous node. Start from the first node. Both current and previous are set to first. Until the specified node is found, until the value is matched, move one node to the next using previous is assigned with current, current is assigned with current dot next. Previous is assigned with current, current is assigned with current dot next. We already know this part, but this is the newly added section. Previous is assigned with current. Previous එක current එක බවට පත් වෙනවා. Previous is assigned with current. If current is this one, previous would be this one. Previous is assigned with current. That means previous would become the current. So current would become the previous. Current is assigned with current dot next. Current would move to the next one. Previous would move to the previous current. Previous would be moved to previous would move here, current would move to the next. That's what. Other than that, other things are most of the same. If value is found, stop moving to remaining nodes and set previous nodes next to current nodes next. Then finally return the current. So this is, we starting with the first one. Previous and current both are assigned to the first item. So then current is assigned to current dot next. And we check the value. The value is found, fine, right? Now we have to delete this item. We have to delete this item. So how to delete that? Simple. Previous next is assigned with current next. Previous items next is assigned with current items next. Current items next means this one. Previous is assigned with that one. Right. So let's go with this, right? Previous. Current. So I'll go them like this. The beginning, previous and current would be assigned with the first. Right. Both are waiting to this. Then current is assigned with current dot next. Current dot next. Current dot next means this one. Current is assigned with that value. Now current is if so, then we compare the value. Right. We want to delete, as I told you, value with 350. 45. මේක තියෙන value එක තමයි මේ value එක තියෙන item එක තමයි delete කරන්න. We check the value. Values are matching. Oh, now we have found the value. Right? Then, so we have to delete that. How to delete that? When we are deleting, we need the help of the previous. Previous is assigned with, currently previous is having previous next is having current. See, previous dot next. Right. Previous dot next. Previous wala next කියන එකේ value එක කීයද නම්? Then it is same as current. It is same as current. Previous dot next, value of previous dot next is same as current. This value. What we are going to do is we are going to change that value to current dot next. Current is this one. Current dot next means this value. We change this value to this. We change that value. Then this one is not referring to that one. That one will be referring to this. Previous dot next is assigned with, what we do is previous dot next is assigned with current dot next. කලින් තිබ්බේ එකේ value එක current dot next කියන value එකට mark කරනවා. Previous dot next. Next. See? That's what we did. Now, previous is pointing directly to the current's next one. Current's next one. Now, the first part is okay. Then, what we have to do is current dot next is assigned to, what we have to do here is we can assign this to null. It is not necessary, but we can do that and then return this current. So it's using the same method here. Let's go with that implementation, right? Current is assigned with first, and then additionally, this is having previous. Previous is assigned with first. And then we have while And then if next, current dot next is null, return null. Else, previous is assigned with current, current is assigned with current dot next. This part has been added. That's all. There are two lines are different. Instead of this one, we have previous is assigned with current, current is assigned with current dot next. That's the only difference here in between. So after finding this is finding part, right? Then deleting part is this. First line. Previous dot next is assigned with current dot next. And then first is assigned with first dot next if current is first. Current කියන එක first නම්. පළවෙනි තැනදීම මේක හම්බුණා. Right. If this one is there, then we have only one item. We have only one item. We don't have two items. Then previous and current both are here. So we have to delete the first one. Not so there could be many values, but the delete value to be deleted is found at the first position here. Now previous and current are both pointing to the same. At that point only there's a difference. First is assigned with first. So otherwise, any other place, previous dot next is assigned with current dot next. So additionally, we can add current dot next is assigned. We can add current dot next can be assigned with null. Current dot next can be assigned with null. That means current dot next is still pointing at this one. Instead, we can just put current dot next can be assigned with null. Right. So anyway, this should do. This will do. So we are deleting a specified. So I'm not going to write it, right? So you can write it and you can check. You can come up with different implementations. That's fine. So is it clear? Is it clear? Do you have any questions? Right. So that's all we can do today. So any questions? So if you can understand what's happening here, then implementation is just something else. So at least if you can identify what's happening here, that's the important. Right? Later on, you can check the implementation and you can understand that. If you can understand actually what's happening, රෙදි මේ කරන්නේ හොයාගෙන යනවා එක තැනකදී අපිට හම්බුණාට පස්සේ ඒ ඩීල් කරන්න ඕන එක්කනා ඊට කලින් එක්කනාට කියනවා ඔයා අල්ලගන්න එහා පැත්තට යනවා අපි මෙයාව අයින් කරන්න යන්නේ ඔයා ඊළඟ එක්කනා ඔයා අල්ලගන්න කියලා අපි මෙයාව අයින් කරලා ගන්න මෙයා තාම මේ අර පස් එක්කනාව අල්ලන් ඉන්නවා අපිට ඕන නම් ඒක නල් එකක් දාලා මෙතන චේන්ජ් කරන්න පුළුවන් ඒක නැත්නම් කොහොම හරි මෙයාව එහෙම රිටර්න් කරලා තාන්න isolate කරන්න Any questions? Okay, right. So I will add these notes to the LMS, and then actually I may need an extra session to finish the next part of this data structures and algorithm linked list. Double-ended list, sorted list, and doubly linked list. Concept-wise, those are not difficult. The concept is very simple. For example, doubly linked list. So we have a connection to the next as well as the previous. Next and previous. When we implement, it would be a bit complicated, but the problem with the current linked list, it can go just one way. It can go to the next one. If we go after going next one, we cannot go this way, previous one. If we want to implement that, we have to go with doubly linked list. Doubly linked list means they can go both ways. Right? Doubly linked list. And double-ended linked list, only difference is, so we have first as well as last. There's a reference to the last as well. Previous implementation, we had only first. Additionally, we have last. Antima එකටත් කෙලින්ම යන්න පුළුවන්. That's the only difference. So otherwise implementation, like it would be very easy. Nothing much difference, only difference is that in a doubly linked list, so we have next as well as previous. Right, so to link all these and then implement just one linked list data structure or one linked list class. So I need another additional session. So can we have it within this week? So that means tomorrow, or at least, I don't know. I mean, for me, Friday is also fine, but I don't know about your case. So can we have it additional session maybe tomorrow or Friday? Saturday is also fine for me, right? So discuss among you and let me know a time to do. So if I have another 2 hours, that would be more than enough. So Johan, just let me know, right? Right, okay. So I'll upload the assignment 2, right? In assignment 2, what you have to do is, so you have to implement a linked list. Using that linked list, you have to implement stack and queue. That's the thing. You have to implement stacks and queues using linked list. So this is the assignment. So actually I have given a class, class called car.java. So it is there, right? Public class car, right? There are several methods, and then, right, those are there. Car, right? So then I need a linked list to store car objects, right? So in our implementation, so we implemented our linked list node to store int. Instead of int, we may have to use car, right? To store car objects, and then implement this linked list with these methods: insert first, delete first, display first, insert last, delete last, display last, and is empty. These methods should be there. And then implement a stack and queue using this linked list, right? So the deadline is not same one. So that's the last one. The deadline could be in maybe 2 days. Yeah, around 2 weeks. Sorry, 2 weeks. Deadline would be in 2 weeks. So I'll upload it and I'll decide the deadline and then I will adjust that, right? So that's the assignment 2. And let me know soon. So if you finish the second part of linked list, so then you can immediately start doing the assignment. Right. Right. That's all for today. So let's meet soon for the second part of this, and then we can go to the rest of. So after this linked list, so we have pseudocode and then recursion. So recursion, we have already done that in first semester, right? Some additional stuff are there, so that's all, but it's not going to take much. And then we can go for binary trees. That would be the last topic for the semester. Okay, so that's all. Thank you for joining, and see you soon for the next session. Have a nice week.